So.
Even though that you're are more similar to the
Want to go?
Thank you.
Let me just put this up there. Sorry.
Are you nervous?
Oh, yeah.
Yeah?
Definitely. Buenas tardes, me hablar en español. Soy portugués.
Hablo en
Portugués.
español, hombre. Lo bonito sería que pudiésemos hablar en español.
Un poquito, porque también
Hablas un poquito.
Sí.
Estuve viendo tu presentación y me parece una cosa muy, muy interesante.
Sí. Otra cosa, he nacido en Barcelona. He nacido en Barcelona.
Ah, ¿sí? ¿Dónde?
Terraza.
Hostia, yo estuve viviendo en Terrassa.
¿Sí?
Mi madre es de allí.
Mi madre también es de Terraza, de
Oye,
de
oye,
Montserrat.
qué bien, oye.
Solo a los 2 años, pues mi padre es portugués.
You know that you're on the speaker.
Already?
Yeah, it's turned on.
Ah, sorry.
Good. No, now we are on.
So before you tell all the secrets about your mother.
1, 2. Okay.
What time do you have?
11.
11, yeah.
But my watch is 2 minutes.
11.
My watch
Yeah.
is 2 minutes.
It's 2 minutes.
I think it's 1 or 2 minutes ahead.
Yeah, that one is way ahead. It's 5 minutes.
You can, if you wish, you can.
I hope you all got your coffee. I think we're about ready to start this first parallel session of today. This session is about how to communicate using the network. It's called Degrees of Presence, and that alludes to the fact that you can communicate using different modes, such as only voice. You can use voice and video. You can use voice and text. This session is mostly about voice over IP or IP telephony and video conferencing, and even something about high definition video. We have 3 speakers, and the first one is João Carvalho from the the Faculty of Engineering at the University of Porto. He's responsible for the software deployments on campus and has been working on grid and identity management. And most recently, he's been responsible for their voice over IP implementation, which he will tell us more about. So please, João.
Oops. How do you put this one? Just click the mouse, right? Okay. Good morning. I'm representing Faculty of Engineering of Porto, as Monte said. And I'll be talking about the project we started about 1 year ago, and had become very stable, and we are now deploying it to other sites and other locations. Whoop. Where's back?
I think you can use the arrow keys is probably
Okay.
if you want to go back.
Okay.
Just
Thank you. First, what I'm going to talk about is why did we choose VoIP? The second is what is our current setup. And PolySpeak, it is what the system is named. We try to put in a name that's easy to remember and very agreeable. And at last, I will talk about the future, what we planning doing about this. Why choose VoIP? Basically, the implementation is cheaper because hardware costs are lower. We have also lower rates, access to brokers, international brokers, right through the internet, instead only about local providers. It has more functionalities. It is possible to integrate with local systems, and the maintenance costs are very low. This was what we were searching for. We first tried to go to professional solutions. Some solutions covered some parts, other solution covers other parts. But when we found a solution that could add everything, it was so expensive we could not afford it. So we turned towards the open source market, let's say, and we choose Asterix as our basis to start the development of the system. So what did we achieve, or what was the main focus in changing? First, in cheap implementation, we can use any machine we want. We don't need a dedicated machine for the purpose. So if you want something very stable, of course, you will not pick up your laptop or something like that to install it. You could do it, but if you have power problems, fan problems, or hardware problems, you will have serious problems later. You can reuse your current network. You don't have to build a secondary network, so your current network will do sufficiently. Even people say, okay, but I have to double my network. If I put a hard phone on an office, I will need one cable for the hard phone, one cable for the computer. That's not exactly true, because you can pick up phones that have switch integrated. So you just put the exit of the socket in the phone and then put the next cable to their computer. And you are reusing your own system. You don't need to double your network. So there's no cost associated with it. Hardware for normal computers are cheaper. If you have to change your memory or something like that, you just go to the next store, buy your memory chip, go and insert it in the computer, and that's it. There's no need to ask your Alcatel or Siemens provider, I need no more memory or I need more plates. So there is no cost associated with this also. One advantage of choosing, I don't believe this could matter. Now, another advantage of this is no special brands are needed. You can buy a Cisco phone, you can buy a Polycom phone, you can buy an Astra. There are many brands available on the market, and you can use them all. The only main focus is it has to be SIP compatible. Some brands do try to change their SIP version a bit so it's more compatible than others. For instance, if you buy an Avaya, for instance, the phone will work perfectly, but when you start using your voicemail, you're going to have some troubles. That's a simple example of what could happen. Now, another advantage of VoIP is you have lower rates. You can access international brokers. Maybe you have heard something like VoIP Buster, VoIP Cheap, and other providers like this. that even have 3 minutes, so you can reuse those minutes for your calls. The quality of the call. Okay, most of the times it's very good, but if you have internet strangulations, you might have some small problems. But if you have do your QoS until your exit router and your OSP provides you with the correct bandwidth, there should not be a problem. Enum is a feature that's scaring a lot of telecom providers because most of your calls are routed directly through the internet. And they make a lot of money using local calls. Okay. What does Enum do? Enum simply translates your phone number into an internet address and sends your phone call directly to the internet address. These internet addresses normally are SIP, but can also be used as EAX2 or even email for if you have a browser, an email browser, and you want to send an email. You don't know who this person on the other side is. Just put in the number. The MTU will change it into the email, and you can send an email directly to a phone number. Local trunks are also very important. If you have a university campus and there are several buildings scattered throughout the city, it would be very logic to interconnect them all into one single system. But because it's not very safe to put some calls through only through the internet, it would be wise to put in each building one server and then interconnect them all in a way so that all calls are routed. For instance, if we have 2 locations, you could say each location has about 1,000 phones. You can say in one server, okay, from number 1,000 to 1,999 is on this server. The 2,000 until 2,099 is on the other server. You simply need to add some routing, just simply interconnecting them, and those calls are all routed through the internet with high quality. Normally, local bandwidth is very easy and expensive, and simplest DSL should be enough to do this. Route exchange. Route exchange are also very likely because in this case we have 2 locations. You don't need to access, let's say, have that many incoming calls on one side and have the many number also on the other side. You can route the incoming calls through one server to the other one. Okay? In this way, you don't need to buy, let's say, 2 primary ISDN interfaces on both sides. You can buy as one primary ISDN on one side, and on the other side simply buy a basic or 2 basics interfaces, so it's for emergency purpose only. Now, functionalities. One of the most advantages of VoIP is mobility. Being able to be in this conference, pick up your laptop, start your soft phone, and simply call your colleague that is in the university on the other side. And there's no charge for this. You also can receive calls. If somebody calls you at the university, then the call is redirected to your laptop. It rings, you can hang it up, you can answer it, you can redirect it to another extension. There are many changes, many things you can do with it. But it's like you picked up your phone in the office. So there's not much difference between one and the other one. Voicemail integration with email. Many users use it. It's very, let's say, fun, because when the voicemail is left, the user will get an email with the sound attached. So he can hear the sound and then later decide what he wants to do about it. IVR, interactive voice response, is another feature. Most PBXs also have some limited options of this. Here we can do something else. We have created a situation in our faculty that does the following. A student wants to call the help desk. The first thing the student will hear is, please insert your numeric ID. The student enters his numeric ID. The call is then sent to the queue. Inside the queue, he will be waiting, and the help desk clerk can see which other users there on the queue and can select them. Once he is selected, the help desk technician will have access to all user information. He does not need to use the web page. He does not need to use any kind of additional means to obtain this information. You can see when the student has entered the university, if which courses he is frequenting. You can see almost everything about the user. So it's much more easier doing this via an XML interface from the phone than doing this directly using a computer and a phone at the same time. Lowest cost routing is a very important issue of VoIP. Most centrals like Siemens or Cisco have a feature that says LCR, but we're going to see later on why this LCR is a bit different. This LCR does not come with Arthrex by default. We have to develop this in order to take advantage of certain situations. Last and final, in this category, we have that it's very user-friendly. Okay, Asterisk is not user-friendly, but you can add some add-ons you can find in the internet that makes it more user-friendly. One thing very important, at least at our university, is the integration with our local information system. So when a user enters, it would be not very, let's say, it would be not very good that somebody has to create his account. Therefore, we did something more simple. We integrated it together with our information system. So once the user is created centrally, it automatically is created also a VoIP account for this user. In this way, it's much more simple to manage all the users that we have. Pin changes also. Normally, you will find that protocols don't have authentications. For instance, if you use Skinny, which is a Cisco's native, it basically does not have any authentication. Authentication is done by the MAC address. And that is not something we did like. So is H323, if I'm not mistaken. But SIP and EX2 has authentication. You can do an authentication using the login and a PIN. I say PIN because a password is not very suited. It's very hard if you have a hard phone and you want to enter your password. For example, for accessing a voicemail, how do you put letters on it? So the PIN has to be numeric. It can have 6, 8, or 10 numbers, but it should be numeric in order to avoid problems. Now, billing information is a very important factor also. If you don't know what your users are using, you cannot negotiate lower rates or better exits or optimized routes for your exit ports. So you have to know what users are using, where are they calling more, where are they calling less, how are they doing this, in order to get the best dial plan. In case our students, it would be not very likely that we would let them call free and then later charge them. So we changed this. This does not also not come with asterisks by default. We did a preventive accounting. So the user has to transfer a certain amount to the VoIP system, and then he can use it as long as he has credit. Once he reaches a point about 1 minute until his credit runs out, he was going to get a message like, you have 60 seconds left, and after that, the call is then shut down. Now, we still have another feature, which is the maintenance costs are low. First, normally universities have 2 departments, one for communication and one for networking. In this case, the networking department and the communication department can be once only. This way, it is possible to reduce some costs. You may not reduce workers because the workers that install the phone need also to be there. You possibly have to re-educate them into the new technology. But in the other part, You don't need to buy support from Alcatel or Siemens. You can use your own configurations. So that will spare you lots of money. And if you try to migrate your machine from one building to the other building because you are changing or something like this, it's simple like unplugging it in one side, taking it to the other side, plugging it in, and you are ready to go. There's no special configuration, no special care you have to take about the phones. Just plug it out on one side, plug it into the other one. Because it's a software, it's basically you only have to do software patches in order to upgrade it. Problems that maybe what brings is you are using your network. Because you're using your network dependent. If your network fails, basically if somebody calls you, he can't call you. It's an advantage for some administrators that says, okay, I will not get the bugging phone calls, my network is down. But it should not be seen like this. It's a really problem. What can you do to avoid this kind of problems? Basically, take care how you configure your network. Use separate VLANs to do this. And also, you can use power over Ethernet and uninterrupted power supplies to prevent that the phones have any problems. Emergency call routing has to be done always through local providers. You cannot route a 112 call through an internet broker. He will not accept it, neither can he accept it. So you will need an ISDN or an analog line to route this call through, and they have always to be available. You cannot stop people from using these kind of numbers. Now, the sound quality definitely depends on KOS. This is our setup. You can see 3 machines. You can see the VoIP A, VoIP B, and the VoIP. Basically, we have one server for our students, one server for our staff, and the other server is only there because the access to our PBX is so far away, we had to get another machine. It's nothing special about this. We can also see we have 1,000 DDs on one side and 100 on the other side. This is kind of a way that you can see how calls are working out. We started very low and then have been increasing each time more. The funny we could figure out is that international calls have an average time of 10 minutes, country calls about 4, and local calls are very short. So if you negotiate a contract with a provider for international calls, if he asks for a little charge at the beginning, it's not a bad thing. If he asks for a little charge at the beginning for a country call, then it's a bad thing. What does Polyspeak brings, basically? We have a web interface, optimized configuration, so you don't have to worry about this, accounting, statistics, an easy backup and restore system, and export-import features. As you can see, this is a simple interface. This was the interface for the user, for the end user really. That's not something you're going to see in other places, because we think the end user should have interactivity with the system. So for instance, if the user wants to call me and is in another university, he just writes my email and does a call. It's much simpler if you work with emails instead of numbers. Emails normally you can remember. Numbers, it's another tricky thing. Furthermore, pin changes can be done on this interface, which will also do something very important. When the user changes his pin and has a hardphone associated with it, the system will access remotely the hardphone and change its configuration. It would be not very wise not to doing this, because when many users change their configuration, it would require the administrator to log on to the remote hardphone or give the user access to the hardphone so he can configure it. And that normally goes always wrong. We also have features like blacklist, whitelist, click and dial phone books, and also some special features under his phone like quick dialing that you can configure right through the interface. Now, the super user is somebody that has not administration privileges, but it has a medium access. He can see basically all statistics and everything that's going on the server. He can see ongoing calls. He even can terminate ongoing calls. But the principle is he can see the information here. You can see here ordered by group. There are many ordering. You can see individual users, group by cost centers, and also where your calls are going through. If they're going to Germany by mobile, or if they're going to France on a landline, you can see how many calls go through, and you can then see how many brokers you will need. This is the administration interface. As we can see, this is in part where the backup is done. It's very simple. You can export it, import it, apply it, and apply it in detail. Basically, you can apply, for instance, your network configuration, but not apply the rest, or individually by its claim. Important thing is most network administrators don't understand much about ISDN or, I mean, more this kind of cards. So the system auto-detects its information. This is the LCL logarithm we used. Basically, it has the ability to get the rates automatically from the provider's website. You don't have to put it in writing. He simply goes there, gets the rate, gets local credit, and gives you the information. And based on this, will choose the lowest rate and will try to get out from that, from that broker. If you cannot, he will not give up. He will try the next rate and will go out through that broker. Users, user usage is very easy to add. It has also groups and accounting centers. We have also added another new feature, which is user routing. You can route depending on the user. As we say, power trunks is something that I did not mention, but power trunks will transfer entirely the users from one system to the others and from one system to the others in a very transparent way. Configuring phones is simply just put in the IP of the phone, add it, and the phone will work directly. As we already talked about IVR queues and callbacks. And what do we do in the future? We want to integrate our system with video conferencing. We have tried out, we have some success, but there are some codec problems still because one phones use different codecs, and there is some trouble there, but we are getting to it. We also want some SOAP service so we can configure the machine remotely without using the interface. Integration with LDAP, AD, or with radios is what we are also looking into. Also, integration with Java has been forthcoming. Definitely, fault tolerance and load balancing is another issue we are addressing. So I think I got it in time.
Thank you very much. Are there any questions? Lots of them.
Hello, Helmut Selene, Rechenzentrum, University of Würzburg, Germany. One question, you mentioned saving costs as one of the advantages of voice over IP. However, you also have to include the cost of the manpower it takes you to configure all of this. Can you tell me how much manpower has gone into this so far for how many users? And the second question, have you considered encryption yet, as in SRTP and SIP-S?
Okay. The manpower is our own network department at the moment. We are about 5 users. 2 of us are very linked to the VoIP system, and 1 is more as a backup. So 2 men in 1 year, basically, and we reached this point. Now for the second process, yes, we're analyzing SIP-S, but we have had some problems with some phones that does not support the specification correctly. And it's a bit complicated, a bit tricky to put it to work. If you support it and the other party does not support it, you might have some problems there, but it's only a question of time. Definitely we're going to pass it through secure layers sooner or later.
Good morning, Cameron Zakon from the Belgian government. So in relation with, first of all, enums and also the fact that you are using LCR, my question is the following. So if you plan to use enum or use already enum, do you have already within your country the legal, let's say, agreement or the legal administrative stuff which is there in order to enable the telcos to know that this prefix is associated, for instance, with your university, because that's current issued nowadays, which means that if it is feasible and it's already over there, that means that if I am using my TBSP right now and is enabled, it will not go out to the PSCN to call you and directly go to your direction. That's the first point. And the second point related to LCR is when you use those different providers where you do not have a specific agreement, so it's just an account and not specific DIDs associated, do you encounter problem with your users, maybe academics, where when they make phone calls, sometimes some need, on some administrative point of view, that their numbers appears on the display on the other side. And when we use LCR, so do you have a kind of dialing plan also which says, okay, now I need to make a call with a number, then I will select that gateway where I know that this is the number I have the right to use?
For the first question, enum is still a problem in Portugal. Okay, the legislation is not coming out, and I don't think it's coming out soon. They're trying, but there are a lot of resistance, which is logically, because there are many people who might lose a lot of money. So what we're doing now, we're using the ORCH and the COM international domains, and we have created our temporary domain to remediate the situation so that our local users can use a secondary, third domain in order to work with it. So possibly you would not be still able to use or call me directly, but you can use anonymous SIP for that purpose. Just write my email on your phone and it would work. We are trying. We are still in the early phase of enum, I think, but it's also a question of time. Now, for your second question, which was... Okay. Yes. The providers do not do this. Most likely, when you call a provider like Betamax, it's going to be very logical that you can go out through Hong Kong or through any Asian country. So he cannot assure that the DI will come. In order to do this, you still have your ISDN, and you can use it. So what would you do? If a user really wants to use a local call, which he has to use, then he just uses a new prefix. Let's, for instance, call it 8 instead, and then the number. He will route out directly through ISDN, and he will not route out through the international brokers.
Any further questions?
Two questions. Do you somehow deal with mobility and emergency calls? And the second question is, do you plan or think about making your management and administration solution available for others, either open source or somehow licensed? Or
first question, it works, okay, but it's not recommended. When you do an emergency call, the other side has to know where you are. For instance, if I'm down here 112, basically I'm in Denmark, and the provider will see, oh, it's a call from Portugal. So it's a problem. You cannot use your mobility with an emergency call. It works, but it will create very... To be honest, yes, to be honest, I didn't even consider this. So that you talked about, I will definitely have to forbid it, without any doubt. We can't let these calls go through. Okay. For the next question, we have been deploying the software in other locations now, And there's still a question that maybe my colleague later on will be able to answer it better. But we might be something half commercial, half open source. Okay. We still don't know exactly what we're going to do. Later on, you can talk to a colleague of mine that will be more able to answer this kind of question.
Okay, we don't have time for any more questions. Sorry. Please try and find the speaker during the break. Thank you very much.
Thank you.
And so the next speaker in this session is Erik Leuten, who is a senior consultant at the Katholieke Universiteit in Leuven. He is responsible for video conferencing, both for their new projects and the day-to-day operations of their current offering, which he will tell us about. This one.
KU Leuven is a university in Belgium, in the Flemish-speaking part of the country. It's one of the oldest universities. I think it's the oldest university, founded in 1425. There are 16,000 staff members, and we have in the university itself around 30,000 students. KU Leuven University is associated with some 12 colleges, technical colleges, spread around Flanders, and together we have 70,000 students. KU Leuven is also a member of the LERU and the Coimbra group, two groups of universities that have a lot of international contacts. I state this because we are using video conferencing to have a lot of those contacts, of course. There are 3,000 publications, scientific publications each year, and around 400 PhDs or doctorates, a lot of them international. KU Leuven is also, I think, every university has them a lot of spin-offs, and of course those spin-offs have also to reach international public. So this is a map of Flanders. It gives you an idea of the distribution of all those associated technical schools. Leuven is somewhere over here, and a lot of the people have to drive to Leuven to get a lot of meetings. So that's why well, it's not that far. It's around 200 kilometers, but everybody has to cross to come through Brussels, and of course with traffic jams that makes it a long trip. At the same time, KU Leuven has also a university hospital, which has 3 sites in Leuven, and around 17 hospitals, again spread all over Flanders around, that have to work together to do some things, and especially to give people a chance to get continuous education. I'm working at AVNet, and AVNet is a central service at the university which is mainly concerned with multimedia. So I'm really not an IT specialist in there. I'm a multimedia man. And in Leuven, the video conferencing systems started in 1994. And it was at AV-dienst, it was called AV-dienst at that time, now it's called AVNet, that they wanted to install those systems. So why did they do it that way? Because normally if you go to other universities, a lot of video conferencing equipment is in the IT department. Well, they chose to do it in the multimedia department because while IT itself is essential to get the video conference to the other side. At that time it was only ISDN telephony, of course. The media support is the more important part. There's a camera over here. I have to stand here to look at the camera. So if I walk away now and get away from the camera, then nobody on the other end will see me. So this is what really is important. And if there is a monitor that gives me the image of the other side, if I put the monitor over there and the camera is over there, then if I'm looking at the monitor to see to the people that I'm speaking to, they will see the side of my face. So you have to make sure that the monitor is just underneath the camera over there, so I can speak to them that way. The same goes for the microphone, the same goes for the lighting. So this is the thing that changes all the time, while the network itself is just another plug in the wall. Together with the electricity, we have to plug it in. Why can we do it that way? Because we have got an excellent support from the people from the network in our university, and we just ask them, please make that plug available for our video conferencing system, and it would be okay. We started a few years with testing and with doing some experiments, and this resulted in two European Commission projects, the SAVI and the BIG project. I've put a link up there, so you can look at them later. I'm not going to explain a lot about them. But in 1996, the Dean of the Faculty of Medicine wanted us to give him a solution to use video conference for continuous education. A lot of the medical people at the university, so the general practitioners and the specialists, had to come back to Leuven a few times a year to get additional information. So they were queuing up in the streets with their cars, coming for a 2-hour session, but they lost 6 hours to do that. And that's why they asked us, is there a possibility to do this with video conferencing? We were very lucky that a lot of pharmaceutical firms sponsored the installation. So we could, in 1998, we could start from scratch. And we could produce something that was really new and challenging in our system. So we had all the equipment new. And in addition to that installation and the installation of a multi-point video conferencing bridge, ISDN video conferencing bridge, we also designed some proprietary systems for the computer presentation that had to reach the other side at high quality, and for fast camera control, so a technician at each of these sites could operate everything, also the camera that was somewhere there, and he could point the camera to the audience whenever that's needed. There is a Pentalpha steering committee, which is responsible for the scientific support, and there were, and that's also very important, of course, 1.5 full-time equivalents from the Faculty of Medicine that were really only there for supporting the project, a half one for administrative and a complete one for the technical support. Before we started the first session, we also did a lot of training to train the lecturers themselves. They've never used video conferencing at that time, so we had to show them what this was. We had to train the moderators for each site and also the technicians that would be there. The technicians, by the way, were just people that working in the telephony switchboard or someone very interested in photography or something like that. They were not real technicians at all, certainly not multimedia people or IT people. So I have to switch now to the video because there is a 10-minute video that explains it much better than I can do, and I think it was alternate. Yeah. Not yet. And then I have to go to, it seems not to be open. The VLC? Yes. Oh, it opened in VLC. Okay, no problem.
Goedendag dames en heren en welkom op Pentalpha, het nieuwe project voor interactief postgraduaat afstandsonderwijs van de faculteit Geneeskunde van de Katholieke Universiteit Leuven. Dit gebeuren wordt u live gebracht in 5 ziekenhuizen verspreid over Vlaanderen.
Dr. Aliet is moderator in Hasselt. Goedenavond, Philippe. Kan je
Dag,
ons
Gigi.
horen en zien?
Goedenavond. Ik zie u. Ik hoop dat u ons ook ziet. Een goedenavond vanuit Hasselt. Er is hier vrij veel opkomst en wij hopen op een boeiende interactieve avond.
En tenslotte Dr. Marien, die ons goed bekend is. Goedenavond. Paul.
Blij dat we er zijn. En wij horen en zien u heel goed.
Oké. Het programma van deze avond ziet er als volgt uit.
All this, which looks rather straightforward during the evening's multidisciplinary session, actually needs a lot of preparation by the panel members regarding the contents as well as the setup. First, participants are briefed on the implications of the technology used for this kind of interactive postgraduate distance learning. The Leuven site is the hub of the Pentalpha structure. Every Thursday night a session is held on a specific topic. The moderator or lecturer is assisted by a panel of experts, each approaching the topic from their own field. This auditorium, the Pentalpha Auditorium at Gasthuisberg Hospital, is fitted out with all necessary equipment for several types of interactive communication, including video conferencing. Its design takes into account aspects such as a speaker's visual angle, the operation of the communication equipment, the possibility of interaction with the technical crew, etc. The expertise in video conferencing, built up by the Linov Audiovisual Service through European projects such as BIC and SAVI, proved extremely useful in this respect. The Pentalpha project is part of KU Leuven Faculty of Medicine's Permanent Education Programme. It has to meet several requirements. Participants should be able to attend sessions at a site close to their home in 5 different areas in Flanders, in order not to waste time in traffic. The interaction possibilities available in these multi-point distance learning sessions should be the same as in traditional working sessions. Images and sound should be of high quality, and it should be possible to integrate media such as transparencies, slides and x-rays in the interaction. To meet these essential requirements, 2 projection screens are used at all 5 sites. On the left-hand screen, the video conferences are projected through a 384 kilobit per second multi-point bridge ISDN connection. The right-hand screen shows the high-resolution images used in the presentations through a dedicated 128 kilobit per second ISDN intranet connection. In Leuven, the 2 screens are part of a permanent setup. The Pentalpha Auditorium is linked to the control room. This allows direct contact between the lecturer and the technician. The setup is different at the remote sites, which alternate between several hospitals. The equipment was incorporated into mobile units to ensure maximum flexibility. It operates on a plug-and-play principle. The equipment includes a video conferencing codec with a camera, 2 video projectors and screens, a computer used for presentations, an additional camera to be trained on the audience, an audio mixer, a document camera, and so forth. Depending on what infrastructure is available in each hospital, the training session takes place either in a multifunctional hall or in an auditorium. Usually there's no separate control room. As we said earlier, the left-hand screen is used for video conferencing. However paradoxical it may seem, the success of a video conference mostly depends on good sound quality. At each site, 2 cameras are set up. The first camera is directed towards the moderator, who in this example is sitting to the right of the projection screens. To ensure that the moderator looks in the right direction towards his virtual audience, his camera is positioned on top of the program monitor. The second camera, centrally positioned between the 2 screens, is pointed at the audience. This camera is controlled by a separate computer. A fixed camera with a wide-angle lens placed next to the mobile audience camera shows the entire audience on the computer screen. Whenever a member of the audience asks a question, the technician directs the mobile camera at this person by pointing and clicking on the computer screen. All participants are supplied with an infrared handset with a built-in microphone. It can be used to ask questions or to participate in a discussion.
Om te spreken moet u continu op de M-toets drukken en van dichtbij in de microfoon spreken. Van zodra u de M-toets loslaat, verliest u het woord.
Goedenavond. Zijn er hier in de zaal vragen?
Ik heb een vraag aan de logopedisten. Tot nu toe ging het alleen over slikstoornissen.
Zijn er hier vragen in de zaal? Ja?
We hebben nou eigenlijk altijd heel veel voedingsproblemen. Heb je daar een verklaring voor waarom dat die trachea-kanule eigenlijk zoveel invloed kan hebben op dit gedrag?
Ja, dat is een excellente vraag. Vanuit de database die we hebben kunnen we daar eigenlijk niet op antwoorden.
The handset also doubles as a voting system.
Wanneer u Vote Now rechts bovenaan het scherm ziet verschijnen, hebt u 30 seconden de tijd om te antwoorden.
Wat kunnen we hier veronderstellen? Deze baby wil thuis nu niet drinken? Of deze baby kan niet drinken? Wat denkt u ervan?
Experience shows that this type of interaction is very useful for breaking the ice and to ensure that everything runs smoothly. The result of the vote is immediately shown at all sites.
Het is fijn van te zien dat u al overtuigd bent van hetgeen we eigenlijk aan u ook willen aantonen vanavond, is dat deze baby waarschijnlijk niet kan drinken.
The questions appear on the right-hand screen as part of the ongoing presentation. The presentation is stored on the dedicated computers at each site. The lecturers control their presentation on the computer they are using in the normal way. The presentation is displayed at the same time at the remote sites via the intranet.
Eerst gaat de verpleegkundige de solving toedienen terwijl...
In collaboration with the lecturers, the transparencies, X-rays, CT scans, etc. are adapted to this new way of teaching. From the start of the Pentalpha project in October 1998, all participants and lecturers have been asked to evaluate each session they attended. They assess the scientific and educational aspects of the Pentalpha system, as well as its technical quality. The reactions show that with Pentalpha, KU Leuven Faculty of Medicine has already brought permanent education into the 21st century.
Ja, er is accreditering voorzien. De duur is 2,5 uur, vandaar dus 25 accrediteringspunten per avond.
Ik vind de kwaliteit eigenlijk bijzonder goed, vergeleken met videobeelden die we via internet soms kunnen kijken en zo.
Interessant. Nee, dit was voor mij de eerste keer. Ik vond het nogal theoretisch.
Ja, ik denk het enige waar ik specifiek voor kom is het feit dat het over een panel gaat die elke eigen facet belichten.
Ik denk het is handiger, niemand moet zich nog zo ver verplaatsen.
Het is toch ook wel voor de eerste keer dat we op zo'n systematische manier samenwerken met regionale collega's.
Dus de technologie geeft ons meer mogelijkheden, maakt het ons niet moeilijker.
Uw diassen gaan eigenlijk heel gemakkelijk. Je kunt videomaterialen gebruiken, dus eigenlijk didactisch materiaal.
Ik vind het fantastisch goed. Ik heb de brieven, de papieren dus ingevuld. Hè. Ik heb enkele positieve opmerkingen gegeven, ja.
Ik vond het wel interessant om eens mee te maken.
Ik vond dat er verschillende thema's goed aan bod kwamen, ja.
Dus ik denk dat de drempel inderdaad veel lager is om interactief te zijn, vind ik. Ja.
Ik vond dat je goed betrokken was bij de dingen die er gezegd waren. Er werden gemakkelijk vragen gesteld en zo. Ik vond het eigenlijk heel plezant.
If you want to watch the video again, you can. I've put the URL underneath, so if you use the QuickTime 7 player or the video LAN player, then that should work because it's a MPEG-4 H.264. It won't work in real or anything else. Originally, the equipment and the system was designed for a 3-year period. We're now almost 10 years further. We have had around 27 sessions each year, so we have around 240 successful or semi-successful sessions. With for each session spread around Flanders between 152 or 190 participants. In total we had 4 technical fallouts. So a fallout is that one of the sites was unable to connect. Most of the time this was due to ISDN provider difficulties or firewall issues when we were using IP. In 2005 and 2006 we had some systems that were transferred from ISDN to IP, so we also changed the multi-point video conferencing bridge to be able to do that, the two at the same time, of course. And in addition to the 5 systems that were traveling around in hospitals over Flanders, there were 10 new systems permanently installed in those auditoria. We're now thinking about taking out the proprietary system we're using to produce high quality material for each of the sites and to use the H.239 content delivery standard that's available in video conferencing. So the new challenges were to move from ISDN to IP, the H.239 implementation. We have some fixed installations. We had to do training and support. We will be doing, and we already are doing, recording for video conferencing, streaming video conferences also, and from AVNet we deliver 3 layers of support. The do-it-yourself layer, we just help the customer to set up a desktop infrastructure for them, explain it a little bit, and then they just use it for video conferencing or probably web conferencing. We have our own facilities, and the customer can book the facilities. We give them a short introduction, but they do everything themselves. And then we give the complete service. We organize the event. This is mostly done with multi-point video conferencing. We have to do it this way. The equipment we're using, we have a fixed installation in key lecture theaters. That's 4 at the moment, and we will upgrade that for the whole of the university in Leuven to 9. Most of them are at the moment Polycom VSX 8000 systems in there, but we've got some others also to test. We have one mobile unit to deploy in university buildings, and then we ask the people from the network or the telephony departments to come in and make the necessary connections. In Flemish hospitals we have now 13 installations. We use a Tandberg MPS multi-point control unit, we use a gatekeeper, and a management system from Tandberg too. And then there is the Kodian IPVCR for recording the conferences. The network is done by the people of KU Leuven Network Services. We have our own VLAN that's spread around the university, and it's in a demilitarized zone. So we're outside of the firewall. We don't have problems with that to do it. I'm just going to show you a quick recording with it for one of those projects. So if you look at this recording, you see the video coming in QuickTime. We've done it here. I think I should press display. Yeah.
Okay, ladies and gentlemen, can we start?
So you get, at the same time, you get the slides that are synchronized.
So
and you can get further if you want to go to the lecture. This is something we added to the Kodian device to be able to get immediately to the right side in the presentation.
And that's why you're going to see a 2-part presentation, one of which was
So again,
Russian
if you press the button and you go to a different site, it automatically will switch the slides to that place also. I think I'm not going to talk about the other ones. You've got the slides, you can link to them, and you can watch one of them in there. This is the amount of video conferences we've done over the last years. So it's gradually going up again, and I think this year it will be much more than 300 if I look at the figures we have already for 2007. Multipoint is staying a little bit at the same level, luckily, because it's rather a lot of work to do it. And what will be the next step for us? Well, we'll have to see if moving from the CIF video format, where you get this type of images together, so you get the presenter and the presentation together, and you have to probably go to high definition video conferencing. Of course, this is much larger. It's a much sharper picture, at least for the video conference itself for the presenter. But the problem here is that you want to have those 2 screens in 9:16 format onto the wall in the lecture theaters, and that makes it a little bit tricky to implement it in fixed installations. I think also here you've got a screen here which is 3x4 area. So if you want to have that, you have to compress everything back again to a smaller resolution or a smaller screen size, and that makes it less readable in there. Okay, this was my presentation.
Thank you very much. We have a couple of minutes for questions.
Hello, my name is Rui Ribeiro. I'm from the Portuguese NRAN, FCCN, and we have made a project a few years ago that was somewhat similar to this. Unfortunately, we didn't have any information. We didn't find any information about this. Maybe we didn't find. Maybe it wasn't available.
It's normally available. If you look at Pentalpha, or you type in Pentalpha in Google, then you should be available to get access to this. Also, the big project describes the complete Pentalpha setup a little bit, but then you have to use one of the URLs to get into that. Yeah.
But I have some questions that, by design, you have some approaches that we didn't have. So I have some questions about that. How many technicians do you use by each room? So
one.
Each during the session also.
During the session, yeah. Okay. So normally the first time we went there, there are two people going over there to set things up the first time. But every other there is one technician there.
All the time to control the cameras and so on.
Is controlling audio, the cameras, the video, if he has to start a video, because that's also possible in there, seeing that everything works fine. He has also, because the slide presentations normally are on CD that are dispatched to the sites. At the moment we're doing it also over FTP to send them to the other side, and then we've built the system around it, which hooks into PowerPoint, takes the number of the slide, takes the coordinates of the pointer and sends them over to the other sites.
I have many questions, and I'm going to post it by email to you.
Okay, or you can discuss it later with me.
I'm just going to make one more question. That is what about the teachers? Do they prepare the presentations? Do they like to use this system? Do they like to go here and present their information to someone on the other rooms?
It's a very good question, because when we started, they weren't used at using PowerPoint at that moment.
And to prepare things.
And to prepare
for
things.
Multimedia.
When they did it before, we had a solution for video conferencing. So one of the lecturers came in and he prepared his slides half an hour in advance for going to that. So that was the preparation, and it didn't look like a real preparation. So there were problems because he couldn't project it. It was much too heavy PowerPoint presentation and things like that. When we started the system, we asked them to bring the material 2 weeks in advance. And we said, okay, you have to bring the material 2 weeks in advance. We're now up to 2 days in advance. Because they now know how to do it. They know it's and they're now starting to use, well, actually, when they did this and they saw the possibility of doing it that way, and they had that technician who treated everything and put it on the screen, they said, okay, I can use this in my normal lectures for the students also at the university. And they're preparing their own lectures now for the students.
They are going to be sloppy when you start H239, because it will be immediately. So
yeah, probably.
Okay, thank you.
Okay, any other questions?
Morning, Comrade Zakon, Belgian government. So one of the trends nowadays in video conferencing tools like yours and many others is to go not only from video conferencing and PowerPoint presentation sharing, but towards what we called collaboration tools, which means having the opportunity on the different panel sessions, on the different participants to use a tool like, a very simple, trivial example, it's a whiteboard, but nowadays we are working till an application sharing, a web page sharing, or a document sharing, things like that. On the medicine work, on medical work, there are lots of many tools that may be really useful for medicine, because I did work on that subject too. So do you plan also within your project and all your list of future tasks to go also towards more than just sharing a PowerPoint presentation or whatever presentation?
Yeah, Yeah, of course, but this is totally different because what we're doing is going from a lecture hall to a lecture hall. And I don't see a lot of people in the lecture hall assisting to the presentation in there. So this should be done, and we're doing it, and I was talking over here now to get some more information about having the capability to do this, but this is from a point-to-point or a point-to-multipoint or multi-point system using something like the Adobe Connect system to make these things work, or to use something like web meeting devices which allow that. We're certainly doing that already in an experimental base, but this was not real video. What we were talking about was video conferencing from a lecture theater to a lecture theater, and the things that were needed for that.
Sharing of the CT, so the CT scan, and collaborating on that CT scan to describe, okay, this side there is this problem. You can make a circle and collaborate on the document itself.
Yeah.
One final question. A short but slightly rude question. How much?
How much what?
How much does it cost?
A lot.
Particularly the remote
I
installation.
I'm
really interested in the remote mobile.
10 years ago, so I don't have the figures with me, but it was quite a lot for each. So you have to calculate the video codec. I really don't know.
Okay,
I think it's something like for each site it would be something between 20 and 30,000 euros.
Okay, all right. And these remote wireless microphone thingies, interesting stuff. Where'd you get them from?
The UK. England.
Okay.
It's a EML, I believe.
Do you have like the vendor information on your slide somewhere, or?
No, it's not on there, but I would not advise to use them because they're costing a hell of a lot of money. They're costing too much. If you use your normal cell phone, you can do the same.
Aha.
But then, of course, you have to put your own server there to be able to do that. But it's much cheaper to do it that way or to use handhelds now.
I guess so, but it's a crucial part of the solution you've chosen.
Yes,
and
that's
it's very
true.
enticing.
Yeah.
All right.
But if you use a cell phone, we couldn't use a cell phone in that time because they weren't allowed in the hospitals. So this is an infrared system that uses infrared that was allowed. But now at the moment there is no problem anymore to use cell phones. Yeah. Okay.
Okay, I'm sorry, but we don't have any further time for questions. Thank you very much. Our last speaker today in this session is, here it is, Jordi Trapero, who is an engineer at i2CAD. And they've been doing some interesting stuff with SIP technology, using it for IP telephony exchange and also some high-definition video over IP. Please, Jordi.
Okay. Well, I'm going to talk about a couple of projects that it's been carried out in EIDOSCAD Foundation. So this is the line of the presentation. In the first part, I'm going to introduce a definition of what service integration means. In the second part, I'm going to define the needed of a signaling protocol for multimedia communication. And finally, the last part, I will be concentrated in show two projects, chip-based. The first one is PitCat project, and the second one will be a platform for delivering high-definition video conferencing. Well, as everybody knows, Internet is not only data services. With the growth of data and video, new networks have been deployed in order to deploy this kind of services. With the appearance of IP, all of these services have been integrated in the same network, IP network. So we have only one network, and we have voice, data, and video delivered over the same network. Some application that we can find at IP telephone, IPTV, email, etc. So, in contrast with data networks, most multimedia communication are connection-oriented services. So what does it mean? It means that they need a signaling plane to establish, to maintain, and to close the sessions. Two major session control protocols are defined. We have SIP, it's an IETF recommendation. It's designed to integrate it into the internet architecture, and main features are its flexibility, text-based, and simplicity. In the other side, we have H323. It's an ITU recommendation. It's based on the ICD protocol, and main features are robustness, interoperability, integration of data, voice, video in the same flow. So, as I said before, we have two main projects in SIP-based communications. It's PITCAT project. PITCAT project main aims is to provide a change point to interconnect ISP service providers of TOIP independently of the signaling protocol used and media codec they use. On the other side, we have a part of machine project that consists of design and implementation of a SIP-based signaling plane for high-quality video conferencing system. The first one, PITCAT project, with the growth of IP telephony traffic and increasing necessity to exchange traffic between operators has emerged. So the question is, how can operators interconnect their IP networks and exchange traffic? We have a first solution that consists on bilateral peering. So that means that each operator needs to establish a peering agreement with the peer that it will peer. So with few peers, it's a good solution. But with hundreds of peers, it's not a scalable solution due to operational cost. Peering through PCTN. This is another solution in which PCTN is used to interconnect two service provider domains. So we need to translate from digital to analogical and from analogical to digital to interconnect both providers. So it's necessary media gateways. Media gateways in the two planes, in signaling plane and in data plane. And finally, multilateral peering, in which a provider is connected to a neutral operator, which is already connected with the rest of operators. So we need just one connection to reach the rest of operators, and all is IP. So it seems this is the switchable solution to avoid the IP islands. PITCAT project, the main objective is design, develop, and roll out of a SIP-based neutral platform called Punto, based upon open source and ad hoc tools that provides an IP telephony peering service, warranting signal interoperability, two-way SIP H323, and media management, so transcoding. Which are the main features of this platform? Provides signaling and media interoperability, so translate from SIP to H323 and vice versa. Multi-domain addressing based upon NUM protocol, call monitoring and generation of CDRs, and implemented using open source and ad hoc tools. It's currently being deployed in Carnage infrastructure to be the first IP exchange point in Catalonia. So if we have deployed already, if we have already deployed internet exchange points, so why we need another infrastructure to provide IP peering service or IP telephony peering service? If we look to the features of an internet exchange point like Carnage in Catalonia or Spanix in Spain, we see that internet exchange point route information in level 3 in IP, meanwhile TOIP exchange point, TXP, route the information using, route the signaling or the media using information of layer 7 application. In internet exchange point, billing is based on capacity, or how many megabits per second are you using to connect to the platform. However, TXP is billing is based on capacity, or it could be also in time. Internet exchange point, low intrusion infrastructure, meanwhile TOIP exchange point have high intrusion infrastructure. That means that signaling and media interoperability, enum-based routing, call monitoring, and so on. And finally, quality of services. EXP prioritizes throughput, meanwhile PXP prioritizes jitter and delay. So this is the full architecture of the TXP platform. We have a BGP network in the top, in which operators announce their internal routes. We have also a Punto Core network. It's a SIP-based network where services that provide interoperability between peer operators are deployed. It's based on open source tools such as Asterisk, 6Expert Router, NusiKey, Beam, and Cobalt Monitor. And Punto Core network management contains the infrastructure destined to provide operational support. So main tasks of this subsystem are monitoring services and infrastructure, billing and data collection, service configuration management, and service provisioning, and finally, travel ticketing. Let's describe some of the subsystem and features. The main aims of call monitoring subsystem is to check call establishment and termination, to provide call detail registers for billing services, and to generate call statistics of call routed by Punto infrastructure. It's based on client-server paradigm, so we need an agent deployed on the SIP proxy that monitors call signaling and generates events for each proceeded SIP call transition detected. So these events are thrown by an RTP traffic sniffer that captures all RTP packets associated to this event. And finally, we have a database to store call statistics. How we solve multi-domain addressing? Multi-domain addressing is solved using a protocol that solves the resolution between VoIP domains. So we need to know how a user is registered in the other network in order to send the signaling and media. So each operator publishes the records on the NUM server deployed in Punto infrastructure. Sorry. And finally, we present Voxma. It's a graphic user interface-based management subsystem. And the key features are service discovery protocol that discovers active services deployed on the network and uses this information to self-configure it. It hosts performs monitoring and service availability, alarm generation, and finally service entity configuration. This is a screenshot of the application. As you can see, we have in the left side, we have the service discovery subsystem with all the hosts deployed on the network and all the services deployed also in the network. So as you can see, we have a proxy SIP, we have a signaling gateway that translates from SIP to H323 and from H323 to SIP, and enum and a gatekeeper. We have also some functionalities associated, for instance, for network diagram, is the screenshot we are seeing, configuration, monitoring, and alarm viewer. And finally, in the bottom, we have all active alarms. Well, related to the machine project, definition of a signaling protocol for high quality video conferencing. Let's see some notes about the state of the art. High definition multi-conference become a key service providing a sense of virtual meeting room for the group. Large corporations and even SMEs are now looking at video conferencing to save time, costs, and the hassle of traveling. Current systems are focused low to medium quality conference systems from 300 to 700 of kilobits. High quality video conferencing systems based on DVTS and ultra-grid. DVTS and video over IP at 30 megabits per second, and ultra-grid send full rate uncompressed high definition video up to 1.5 gigabits per second. They are focused on how to transport high bitrate multimedia data. However, they don't provide a mechanism to control it. Related to signaling mechanisms, we have SIP CMA that follows the principle that any continuous media service can be accessed by using the SIP protocol. What about the implementation solution? The main aim is to get a multi-point, high-quality multi-conference platform. Signaling plane compatible with other device clients, support new formats in the future. And we have developed three tasks. The first one is to develop a zip client that supports high-definition videos with two interfaces, web interface and Java interface. To develop or deploy a media transmission platform using DVTs and UltraGrid. And finally, to become to a multi-point conference, adding a multi-point control unit. It's based on zip and it supports high-quality videos. What are the innovations of this project? It's provide a signaling plane to high-quality video conference system. It uses zip as a signaling protocol, interoperable with all the zip devices, deploy additional modules, such as present service. It's independent of video transmission system, and it uses a simple MCU. So what we need an MCU, basically nowadays multi-class has a limit deployment, and if we want to send multiple flows to each user, multi-conference scenario is not scalable due to the bandwidth limitation. So with MCU, architect is scalable for every user, producer manages MCU, MCU replicates and forwards user flow, and finally any user can become in MCU displacing the operator philosophy. How MCU has been implemented: video flow commutation, replicates and commutes video flows, works on UDP layer, is based on chestnut packet reflector implemented in C language, and support new formats in the future. Signaling plane is based on joint zip reference implementation. It has been added a new zip message called do for producing purposes, and multi-conference session controlled by the MCU. So this is the full architecture of the project. So we have two clients, which each one is composed by a zip client that manages signaling. We have a graphic user interface to control the zip client, and we have the control plane based on UltraGrid and DVTS. We have deployed also a zip proxy that route the signaling packets, and finally we have deployed also a presence agent to control the users and user capacities. Well, that's all for demonstration. Please visit iTucat booth. It's here.
Thank you very much. We have questions now, but please wait for the questions because afterwards there will be an announcement. If you're interested in SIP, Enum, Voice over IP, there will be a workshop tomorrow, Thursday, which Fabio will announce shortly. So we just take a round of questions first and then hear what Fabio has to say. So, Rui again.
I'm sorry, but I'm very interested in these topics. The first part of your presentation was about the infrastructure to integrate operators so that they could interconnect and exchange
traffic.
What does the regulator of Spain say about this project? Is it working right now?
No, currently it's being deployed in EXP that in order to they can offer TOP exchange. So we have in Catalonia we have a internet exchange point called Capnix. So they want to offer also TOP exchange between the operators that are connected to Capnix. So now we are currently deploying this infrastructure in this.
You are making right now the system, okay? But the regulator didn't say anything about it. No one cares. Okay. So any operator that has commercial users can operate with this, or can other NRANs and others interconnect with you?
We are currently working with both Telecom and Malpi that they are in Catalonia. So this is the only operator.
Other questions? Okay, well, if there are no other questions, let's thank Jordi again. And Fabio, before I give the word to you, I have to remind you to please fill in your evaluation forms online. You've been sent a code in your email, and if you fill them out sufficiently, you can receive a small present at the Torina, at the check-in stand, I think. Okay, Fabio, please.
So before everybody runs out, I wanted to recall you in 2 minutes that tomorrow there will be a workshop, a hands-on workshop on SIP, and we will demonstrate how you shouldn't use PIN codes. So we will have man-in-the-middle attack, we will crack password, we will show how to configure enum with fallback mechanisms. So if an enum call is not routed, what you can do else. We will have we will show how to prevent from spit. We will treat SIP identity and many other aspects. So it is intended to be a real hands-on workshop. It will be nice if you have a SIP client, but I think it will be also interesting for all of you. Thank you for attention.
Okay, so it's lunchtime. Thank you again to all the speakers in this session.